Okay, here's another example to help you out with the limit of the difference quotient from section 2.4. This is number 4 on your worksheet if you want to follow along if you're getting stuck. I know there's a fraction in this one. So just to take you back to the concept here, we want to try to figure out the difference quotient. So I'm going to set up slope formula. I know that I have this function passing through 5 comma f of 5, and I don't know what f of 5 is right now, but I'm not worried about that. And I need to pick some other point for it to pass through. So instead of doing 6 or 4 or something like that, I'm just going to do 5 plus h being just hopefully a small quantity. And then my y value would be f of 5 plus h. And then my setup here becomes, let's take y2 minus y1. So that would be f of 5 plus h minus y1. And let's put that over x2 minus x1. That would be 5 plus h. And then we're going to subtract, whoops, delete that. I want to subtract 5 here. I just wrote the wrong thing. We're subtracting that 5. And maybe it would be even clearer if I would label this as x1, y1, x2, y2. So we've got good old slope formula from Algebra 1. It just looks a little bit different because I've got this crazy 5 plus h going on. Okay, the concept is, the calculus concept is, if I take the limit of this function that I have created, my difference quotient, this right here, if I take the limit as h approaches 0 of that entire function, what I'm doing is I'm finding the slope at the instantaneous slope at the point x equals 5, because my 2 points, my x1, y1, and my x2, y2 are basically going to be on top of each other. Okay, so that's what I'm about to do. It is going to take me a little bit in terms of the algebra here to work through this. So I'm going to come back to this screen and substitute in. I'm going to go to my next screen. Actually, I don't think it's going to let me do that, so I'm going to keep working here. Maybe it'll let me move things up and down. We'll see how this works. So f of 5 plus h is the first thing that I need to figure out. So I'm going to go back to my function, and everywhere I see an x, I'm going to put in 5 plus h. That would be here and here. So I've got 5 plus h, and then I've got a plus 1. That was part of my original function, all over 5 plus h. I'm going to see if I can simplify, and the only thing it looks like I could do here is I can go ahead and make that 6 plus h over 5 plus h. Gotta love the fractions. F of 5 is the other thing I'm going to figure out. And that's going to be plug in again a 5 in for every x you see here. So I've got 5 plus 1 all over 5. And last time I checked, that was 6/5. So I'm now going to rewrite. Let's see if I can make a little room here. I'm going to rewrite this, but I'm going to substitute in f of 5 plus h and f of 5 based on what I just figured out here and here. So this is going to become, I'm trying to give myself some more room here, hopefully. Limit as h is approaching 0 of 6 plus h over 5 plus h, that's this part, minus f of 5 is my 6/5 down here, all over, and in my denominator, notice I've got 5 plus h minus 5, and hopefully you're seeing that the 5s are going to cancel, and that's going to give me just an h in the denominator. So now I've got a nice difference quotient in my limit, and the only thing I have to do is simplify my fractions. So I've got some complex fraction work to do. Yes, that would be why we've been reviewing our complex fractions. So I'm going to give myself some more room here. There we go. So I'm working with this, and I'm going to try to get common denominators in my numerator. So I'm going to multiply by 5 plus h. And if you're feeling confident at this point, pause the video, try it, scroll to the end, and check your work. And let's go ahead and get my numerator is going to be 5 times 6 plus h minus 6 times 5 plus h. All over 5 times 5 plus h. That's the numerator all over the denominator of h. The rest is my simplified numerator. And it looks like I've still got some work to do. So let's multiply that out. So I've got 30 plus 5h minus 30 minus 6h all over 25 plus 5h all over h. And I'm finally starting to see something that's going to work out here. I've got a 30 minus 30. It looks like I can combine that numerator to be 5h minus 6h is negative 1h. Just for the sake of consistency, I'm going to keep going here. Let's get that out of the way and see if I can keep going horizontally here. Equals negative 1h over 25 plus 5h all over h. And now I'm ready to deal with my complex fraction times 1 over h times 1 over h. Cancels out there, so denominator's gone. And now I've got an h there and stop it, and an h there. So I've got this negative 1 over 25 plus 5h. And now I have to remember that I actually have been lazy with my notation here and or working on a small iPad and don't have enough room. I'm actually finding the limit as h is approaching 0 of this function. And now I'm finally to calculus, and I'm evaluating the limit, and I got rid of my 0 over 0 problem, because if I would have plugged in at any point until now, plugged in my 0 for h, I would have gotten 0 over 0, but I only have an h down here. So I'm going to substitute in my 0, and I'm going to get a negative 1 in the numerator. 25 plus 5 times 0, this term just becomes 0. So I have 25 plus 0, so I get negative 1 over 25. You just figured out that for this function, f of x equals x plus 1 over x, the slope at x equals 5, exactly at that point, is negative 1 over 25. And that would be my final answer.